In this video, I'm going to teach you how to solve the question on my screen. We are given a unity feedback system that is characterized by an open loop transfer function. Now we need to get the closed loop transfer function. When you are given an open loop transfer function, you look for the closed loop transfer function before you start solving. Plus, minus. For questions like this, your summing points will look like this. And have these signs. So plus 10. Then this is the output. See. Now the closed loop transfer function is gotten by reducing this block diagram to its simplest form. And to get that, C over arrow is equal to K over S plus 10, then divided by 1, and since the sign is minus, sign here is minus, your sign here becomes positive, and this will be K times 1, since it's a unity feedback. What this thing means is that the value here is 1, just 1. Now if you simplify this, C over R becomes K over S squared plus 10S plus K. Now the second thing to do, because we are asked to find the gain K so that the system will have a damping ratio of 0.5. That's the first thing we are asked to find, K. So before we move further, we can see that you check if there is any coefficient, that's a number attached to S squared, then you divide the numerator and the denominator by the number to actually convert to the standard form I showed you in the previous video. The second order has a standard form. To convert to the standard form, divide the coefficients, divide the numerator and the denominator of the transfer function by the coefficient of S squared to convert to the standard form. Now we are dividing by 1 everything, so it gives us the standard form, and we can continue from here. The damping ratio still from the previous video, delta I showed you this formula in the previous video, 2 root Tk. This is the formula we're going to be using. Now we know that delta is 0.5 and B from here is 10, T is 1, and k remains k. So substituting, you have 10 over 2 with k equal to zelta, and zelta is 0.5. From the question, in order to find k, you can cross multiply, or you can cross multiply, or I can actually switch values. This should be 10 over 2 times 0.5. I can actually, and squaring both sides, you have this times 0.5. This will give you 100 squared. This will give you 100. Now we are asked to find, say for this value of k, determine the settling time. Settling time, I also gave you the formula in my previous video. Settling time for 2% criterion is 4 over sigma, and sigma is zelta w subscript n. This, you know that sigma, zelta, which is the damping ratio, is 0.5 times w subscript n is equal to square root of a over t. For this case, k is 100 and t is 1. So square root of 100 is equal to 10. Substituting this here, 10, this will give you 0.8 seconds for 2% criterion. For 5% criterion, you have this zelta. This will be 3 over 0.5 times 10, gives you 0.6 seconds. Which is 5% criterion. Now the next thing we are asked to calculate is peak overshoot. Peak overshoot still gave the formula in my previous video. Peak overshoot MP is equal to exponential minus zelta divided by 1 minus zelta squared times pi, all times 100, because this is in percentage. Now if you substitute the values, this will be minus zelta. The value of zelta is 0.5 minus square root of 1 minus 0.5 all squared times pi times 100. Using your calculator, this becomes 16.3%. That's the peak overshoot, the value for peak overshoot. Now for peak time, T subscript B gives you pi over W subscript D, which is equal to pi divided by Wn square root of 1 minus zelta squared. Substituting values, this is 3.142 over 10 times square root of 1 minus 0.5 squared. This will give you 0.362 seconds. So thank you for watching this video, and don't forget to like and subscribe to this channel for more videos like this.